So welcome to the session evaluation of AI search engine. I have already shared two short videos to get some background of this specific topic. I'll share all these into the description box. So before starting this session, you just please go through those two short videos so that you can get one context of this discussion. So what we have seen with the advent of these LLMs, basically there are a lot of use cases of LLM. So AI search with the help of retrieval augmented generations is a major use case and commonly available in most of the companies in irrespective of any kinds of domain. So what happens now when we build one AI search systems with all the pipelines available, and now the model is completely ready, the system is now completely available. Next step is that we go to evaluate this specific search system, means how is it performing, okay? And for that what we do, we prepare one ground truth test data set, and we define some set of metrics, evaluation metrics. For examples, I have already told that precision, recall, ABRR, that is a mean reciprocal ranting, and NDCG, that is for normalized cumulative, normalized distributed cumulative gain. So what are the definitions I have already described in the short videos. Please go through this. Now my concentration is to come up what is the next step. So we run the complete evaluation pipeline with a specific code on this ground truth test data and come up with some score for these metrics, and that we display in some kind of traceability evaluation capture metrics into some kind of dashboards. We capture in the Langsmith, Langfuse, or our in-house applications. There we see that, okay, for this application this is the average score of all these metrics, and we stop there, okay? But basically what I will say that the actual work starts from here. This is what we described before. This is like working demo application, development application, but it's like system is working, but in order to deploy that into the production, the actual work starts here. Similarly, when one of my client told that my AI search system is inconsistently behaving, sometimes it is giving me accurate result and sometimes it is giving me some kind of answer. I cannot say whether, I don't know what is the reason, whether it is hallucinating or I'm not getting from where it is retrieving those kind of documents or something like that. So in that case, let's dig out how should be the actual evaluation pipeline, this specific use case, AI search engine evaluation pipeline, evaluation framework. For example, if I have says like that, let's come to the example. If my user query is this: in May 2026, why was my AWS compute cost 50% higher than the previous 4 months? Okay. So this is from the complexity perspective, this is like medium complexity. The simple question can come like this: what was my compute cost in May 2026? And some hard test question may come that in May 2026, why was my AWS cost was 50% higher than the previous 4 months? That was a anomaly, slight higher. What are the different regions? What are the recommendations in order to keep it within 20%? So this is like 3 slabs of, okay? For example, the first question was like, what was the compute cost for May 2026? In order to do that one, some of the, it is a simple AWS car report will be retrieved through the rack, and one text to SQL engine will be running on top of that report to come up with a specific answer. When I say this question, in May 2026, why was my AWS compute cost 50% higher than the previous 4 months? Then in that case, what will happen? Some set of reports will be coming, same AWS car as plus billing periods, plus cost anomaly report, plus deployment report, and then it will come up like that, okay, these are the reasons. The third question is that, okay, what is the optimization technique recommendations in order to keep it within 20%? So what is the recommendations means? It will retrieve some of the knowledge document, some of the document where the best practices, so what is the recommendations as compared to the previous knowledge, previous experience, or industry standard best practices will be mentioned, and those specific documents should be retrieved in order to put some suggestions, okay, by following these steps, this compute cost can be limited within 20%, right? So in that case, there are 3 levels of questions comes. So first, let me take it in order to first digging up the exercise. What are the different steps that we are going to follow? One is that the first step is that it is like build retrieval improvement. Second is about measure using ground truth. Measure using, I am writing just ground truth data set. We are having already one ground truth data set. And the third is about we need to do compute CI perform. Compute confidence interval, that is, and then perform variation decomposition. We'll explore what are these terms. And then fourth is that fix evaluation stability, that is repeat all the process. And the sixth is that deploy only when the improvement is statistically significant, right? So the client told me that initial 3 to 4 days the system AI search system was performing fine as per the expectations. No one had reported any kind of issues. But on the 4th day, this senior executive reported that it was not giving consistent results. That means for a specific queries, like some kind of queries, it was giving some random answers. So in that perspective, if when it came to the development team, they thought that, okay, we need to improve the performance of the system. So then they started analyzing the architecture of the system. System was having, it was like keyword based search, the vector search and the hybrid search, which is having both keyword based search with BM25 and the vector based embedding with the cosine similarity based search. Then they decided that now we need to improve this by including the knowledge graph. That will be for the graph rack, and once the set of documents are retrieved, then the text to SQL engine will be running on top of that. So then they decided to include knowledge graph, and after this the complete development finished, and after this they came up that, okay, before the NDCG at K metric, that was showing the value was 0.82, and now it has significantly improved with the value, old value NDCG, you can say like that, NDCG old equal to 0.82 and NDCG at K new is equal to 0.84. That means they have increased 2% with the performance by adding the knowledge graph layer inside that knowledge layer. That is the knowledge graph layer inside that one. But is it significant? Have we done any kind of verifications whether it has really improved the systems? Not yet, right? Then they decided, okay, they have to ship it to the customers. So before analyzing this concept, we need to understand some statistical terminology. So these two statistical terminology, one is this CI and the other one is the variation decomposition. So what is CI? This is known as confidence interval. So, and another is the variation decomposition. So this one specific confidence interval will be used to conclude that there is some noise present in the system because of which the performance is not stable. Okay, and the other one is that to come up to know the root cause of this instability. Okay, so when there is a rule if there are two systems, if confidence interval CI of system A overlaps that of confidence interval of B, then conclude that there is not system performance is not improved statistically significantly. Okay, and the performance that we are claiming, that is not statistically significant. So in this case, you know about confidence interval, that is one statistical term. So what is this confidence interval? Confidence interval, there are two systems. Before it was already system A and the other one is system B. So before deploying system B with the knowledge graph system, we should have one kind of A/B testing. A/B testing means to compare that, okay, the second system has been significantly improved, so that we have to replace the first system. So I am telling that system A and system B. So what is the formula of this system CI? CI is equal to statistical mean plus minus, I can say plus minus Z score product standard error. Okay. So mean means, for example, I have already told that my ground truth data set was having 500 records. Okay, it was having 500 queries. Then what will be and each query is having one kind of value of NDCG at K. Then what will be the average mean NDCG score that we can get this mean. And the Z score consider confidence interval level, significance level equal to 0.05. That means alpha is equal to 0.05. So alpha is used to measure, it is a significance level, and that will be used to measure type 1 error. So when I say that type 1 error, what is type 1 error? Type 1 error equal to type 1 error means it is false positive. That means the system is not actually improved, even though we assume so. It is not statistically improved. So in that case, if alpha is equal to 0.5, if alpha equal to 0.05 means, and that is equal to what is that? This is significance level. And what is the probability of making some That means it's the probability of making type 1 error. Okay. So in that case, what is the confidence to what, if that is the making probability of making the error, then how much percentage I will be confident? I will be confident about 1 minus alpha. That means is equal to 0.95. Okay. And so for this reason, when I say that, when I say how to compute this CI, then I got the mean among the 500. Then I got for 0.05 or alpha is equal to 0.05. In this case, Z is equal to 1.96. So here I can write that Z is equal to 1.96, that you can get in the statistical tables or somewhere through the calculator also you can get it. And what is the formula of standard error? Standard error is equal to variance divided by, this is the variance, square root of variance divided by square root of n. N means is equal to 500. So n is equal to 500. Standard error, this is equal to ST by this. Okay. So in that case, you can get the standard error. It may come 0.01 something. So for both the systems, let me delete all this. So in both the system, if I say like that CI of A, it comes around something like it is coming from 0.79 to 0.85. And CI of B, that comes around 0.81 to 0.87, something like that. Right. So in that case, there is an overlap. There is an overlap between values. So in this case, this implies that what is that? This is not system B is not statistically, performance of system B, the performance of system B is not improved statistically significantly, is not improved statistically significant. The performance improvement of system B is not statistically significant. If this is not statistically significant, then we have to reject this acceptance. That's a null hypothesis. Null hypothesis, what was that? No, that is system B is significantly improved as compared to system A. That was the null hypothesis, and in this case we have to reject that. Now again come back, if that is not statistically improved, then how we have to make it improved in a better version? That point we need to come up with a variation decomposition. So what is this? In order to know, so variation decomposition is required to know the source of instability. Source of instability means the complete system. When a complete system is already there, it has various kinds of components. Okay, for example, one component is that how you are evaluating. You are evaluating based on a data set, ground truth data set, and that data set is having different kinds of queries. So one is that query instability. And second one is that retrieval system instability, you can say. Third one, retrieval system means system A is having 3 engines to retrieve the information. One is that through the keyword search, that is BM25 algorithm. Second one is through the vector embedding, cosine similarity. Third one is the hybrid, both. And system B is having all these three plus knowledge graph is there. So it is a kind of retrieval is there. LLM is that different kind of LLM is used somewhere open source or something is like Claude or something OpenAI to generate the response, right? So different LLMs are there, and then one is that LLM as judge. So while giving some kind of while giving some kind of evaluation score, then in that case LLM is also getting used as the LL judge. So these are all kind of components inside it present. So we need to check that inside the complete system these are different components, how each component is stable or how each component is responsible to generate the final response which is weak, and how we need to improve that one. And all these things we can be able to know through this variation decomposition. And what is that variation means? We need to come up with the variance. So what is this variance? What is the formula of variance? Variance is equal to summation of, you can say summation of x minus x mean. Okay, x minus x bar, you can say like that, x bar divided by n, and n minus 1. So in that case, if the variance of 500 queries that is present in our data set, if that comes around, it's a small value, there's for example 0.005, and another case, if the variance is coming 0.85, that means it's a large value. That means what it says that? It says that the variation is too large. That means it is sensitive to the data. That means model is sensitive to the data. But in this case, variations is stable. Variation is stable. Okay, and the model is not sensitive to the data. So in this case, this is all this kind of calculations we need to calculate. So for example, if I say that these are all the components and the total variation of the system will be 0.1, total variation is equal to 100% or 0.1 you can say. Then we need to calculate what will be the variation of all these components. Then for query instability, for the first one, the query instability having 500 records, we can say that query, what is the query variance, we can come up, for example, same formula. Here the same formula if we apply, then if we come up with some kind of 0.67 something we are coming up, okay, and that means what is that? So it is like, for example, 0.67, that means it is like 167%. And for the query, and this is retrieval variance is equal to 0.2, and LLM variance is equal to 0. When we come up with this formula, then we can see that query variability is the highest number, that is 0.67. That means it is contributing 67% contribution for this kind of instability in the code, in the score. So that means for some queries it is performing very good, and for some queries it is not performing very good. You can take the examples of like easy and the hard. When I went back to analyze the data set, I found that the data set, the 500 queries among the data set, it was completely 350 queries were easy standard, and the 75 were medium and 75 were hard. That means it is like in unbalanced data set. Okay, basically we need to consider the balanced data set. So my first step was to make it balanced. Why we are making it balanced? To reduce this query variability from 67 to some percentage, right? And why this reduction is required? Because with that we can say like that the two systems, the C confidence interval of A and B, the two systems, when the actual traffic comes, they will be performing in a better way. It will be performing. It will not give some hallucinated response for some unseen user queries, because in the during our development or the testing phase, as per our previous traffic, we have to prepare one set of evaluation data set. But in the production, we don't know. The system will face some unforeseen data on which it was never trained or it was never evaluated before. So in that case, while evaluating our systems, we need to keep in the mind that it should be evaluated with all the possibilities, different kinds set of data. So that's why when we say that we need to keep our data set stratified, that means different status should be available there. So in that case, I divided, let me delete everything here. So in that case, what I can say that I have to divide into the 500 queries. Among the 500 queries, I can make easy is equal to total 500 divided by 3. How much? 3. You can say everything. Easy 170 equal to medium equal to hard. So now I have complete 170, 170 and 170, something like that, or 160 you can say in the meantime. But this is like managed. It is a kind of balanced data set. Then after that, what we have to prepare? In this case, again, when we go for this, we have to prepare the variance. Again, we need to prepare the variance. And when the variance comes then you know the formula of this variance. Okay, when the variance of all this for medium, we can say like that variance of EG and then variance of medium and then variance of hard. 3 variance we computed, and in that case our total variance total is equal to 0.1, and then we have to take a mean of that one. So in that case, what will be there? So after that we have to do. Now coming back, we are having 170 medium, EG and the hard questions. Now at this phase, what we will do now? We will coming back to our previous matrix, that is NDCG at K. We need to calculate what is NDCG at K for EG queries. That means for each row, 170 rows, we will be getting 170 NDCG score, and for EG again we will be getting 1 score, average of that one. Similarly for medium also average of something, and for hard also average of 170. So these are individual values. And what is the total mean? Total mean is also for all the NDCG divided by something, it's like 500. So if I say that EG queries, that means it is able to retrieve the documents easily, so that its value will be, for example, 96. For medium, its values is 0.76, and for hard, its value is 0.34. So now you can see the difference, how this mean is varies. If you say like that hard questions comes, then its performance is 34%, and if some easy questions comes, its performance is 96%. But the overall system performance is how much? If you take the average of this, then it will come around 55 to 60%, right? And in that case, you consider that yes, my system is better as compared to the
previous system. But actually when we make the data set balanced, the actual hidden reason why it was, even though score was more, but it was failing to answer certain questions will surface up. So from there we have to take it. So in that case, what is this? If this is this, and then we have to make it very clear